Hello, my name is Jenny and I've been a member of the Essex Bat Group for the last 4.5 years. I've also been undertaking a degree in environmental science and completed my dissertation project last year. I wanted to share some of the more interesting results with you, and so I'm here today talking about the importance of small woodland streams to bats. We had a little trouble with the first couple of slides in the recording, so I'm recording them again, and you may notice the hard cut between future gen and past gen. So, how important are small woodland streams to bats? My project focused on the importance of stream presence, season and temperature on 4 different bat species: the barbastelle, noctule, common and soprano pipistrelles. I'm going to start with a quick overview of why streams are important to bats and their link to climate change. I'm then going to delve into my project and other examples from the Danbury area to demonstrate how even small woodland streams are very important to bats, how variable bat activity can be in these woodlands, and why surveys and woodland management should take temperature, season and stream presence into account when doing any management or designing their woodlands for the future.
As many of you will already know, riparian habits are very important to bats. They are important landscape features that can be used as commuting routes. They can provide increased insect densities and are valuable feeding areas for many bat species, and they also provide a source of water for bats and other animals. However, they are threatened by human modification, widening and straightening of rivers and development alter flow levels downstream, thus seemingly protected areas like our woodlands can be damaged. They are threatened by pollution, particularly from agricultural runoff and degradation of surrounding habitat. Cool. This is good. So, bats are highly affected by temperature. They're small mammals with thin wings that are full of blood vessels. This means they can fly around and are extremely adept at catching their prey, but it also means they lose temperature quickly. Their energy demands are very high, as both flight and echolocation are very energy demanding. So they don't have to spend lots of energy keeping warm. Bats enter torpor when temperatures fall. However, it's a difficult balance. Bats' energy requirements vary throughout the year, for example, increasing during pregnancy and lactation, and the temperatures are always changing. So this balance that bats have to undertake changes every day. And the balance is again further complicated by climate change. Climate change is one of the biggest threats to biodiversity in the 21st century. Climate change has been shown to have negative impacts on bats, with some recent models predicting a reduction in water, bat abundance and species in some areas, including places including our country and in Ireland. Insects, our bats' favourite food, are also affected by temperature, a double whammy. Temperature affects insect development, survival, range and abundance. But insect density has been shown to affect the timing, location and number of foraging bats. Many of the insects UK bats feed on are associated with water, including streams. So it could follow that woodland streams are especially important to bats, providing opportunities to both feed and drink, but this would all be altered by climate change as temperatures increase. Understanding how bats use these streams and the streams around our areas could be very important to climate change mitigation. So, my project focused on the woodlands around Danbury. It's a small village to the east of Chelmsford where we're already collecting data for the Danbury Barbastelle project. I surveyed 5 deciduous woodlands around Danbury. These were Danbury Country Park, Blake's Wood, Hollybread, Wood and Water Common and Paws Peace. And I'm very grateful for the continued support of all the landowners and managers for allowing me to record bats on their sites. You can hopefully see these woodlands are all the woods that are clustered around Danbury. So you've got the main Danbury in the centre here, and then the woods are highlighted yellow on the outside. And what you can also see on this map is how well connected the streams in these woodlands are. They're connected to the Sandon Brook and the River Chelmer, which flows out to the Heybridge Basin. I've zoomed in here just to show you a little bit about what I did. So I simply placed bat detectors at randomly generated points along woodland streams and paths. To try and keep things fair, I put one detector along a stream and one along a path and made the recordings concurrently. I put detectors at comparable heights and directed the microphone over the centre of the path or stream. I also directed the microphone away from clutter, as this can reduce the quality of recordings. I used the same recording location on multiple occasions to try and assess the impact of season. And although this was the method I took, we couldn't be as rigorous as we hoped due to the outbreak of COVID-19, which stopped data collection on a few occasions, but we won't worry too much about what happened last year. But for the study, what it meant was some sites were sampled more often than others, which resulted in a slight bias from those sites. The dataset isn't as complete as I wanted, but the results I did get were interesting nonetheless. So here's a couple of the paths that are amongst our woodlands. You can see here's a nice wide ride with established vegetation. There's a couple of different months these were taken in as well. Just to get you in the mood, here are a couple of our woodland streams. And you can see they do vary an awful lot. And the size of some of these streams are quite small. So what I found, which wasn't very surprising, was that the number of bats and the amount of bat activity I found varied between the sites, and it varied between woodlands and streams, and it varied between the summer and the winter. But what was more surprising is how much it varied. I found over 30,000 bat calls during the sort of 7-month period, and this was a huge amount of research and a huge amount of analysis to do, which kept me very entertained during lockdown 1. So what a couple of things did I find out? The maximum number of calls I recorded along a woodland path was 848. The maximum I found along a stream was 2,254, almost 3 times as much. This alone got me thinking. So I found the biggest difference in the common pipistrelles just here on my graph, where they showed that their preference was to fly along the streams. I believe this is because their food, flies and gnats, are associated with woodland included damp areas, and I think the streams in Danbury are particularly important to them. I expected a similar result with soprano pipistrelles. They're also known to associate and feed over water, and many of you will have seen them feeding over ponds and lakes, including the lake at Danbury Country Park. But I didn't actually see this. I found that soprano pipistrelle showed very little preference between the woodland streams and the woodland paths. On average, almost 50% of activity was found along each. And I think the reason for this is because I didn't include any of these large ponds and lakes in my study, because it was focused directly on the smaller woodland streams. And I think these pipistrelles could be off feeding and flying over the woodland ponds. Only the nocturnal showed more activity along woodland paths and streams. On average, 75% of the calls we recorded from nocturnal were over woodland paths. Again, I think this may be because of their preference for more open habitats. They're much larger bats, and they won't be able to navigate down these small corridors and the cluttered woodland that's along some of the streams. So they may have been choosing not to fly or feed over the small streams that were at Danbury. Okay, this is a slightly complicated graph, but bear with me, I will explain it all. So what I found here was that the activity of bats along the woodland paths seemed to increase as the spring progressed and the temperature increased. You can see here in the grey line, the temperature increases as we go through the months, and so too does the activity along the woodland streams. It then seemed to level out during the summer and slightly reduce in the later summer. Now, this could be because they have decided to go somewhere that has more food availability. Said before that these woodland streams are a hotspot for flies, gnats, all those little midges that bats like to feed on. And it could be that they are choosing to leave the woodland paths, go to the woodland streams and eat while they commute. And it would be more important to them to do that in this late summer while they're pregnant or lactating and they need more energy. I did record this little peaking activity on October when the temperature raised as well. And we're going to come back to that point later. So I found overall that the activity was higher along the woodland streams than the woodland paths between mid-May and mid-October. You can see in the blue here, there's higher, and almost every day more activity was recorded along the streams. It wasn't a fluke here that we got. So there was no obvious preference outside the peak season about whether the bats were preferring to fly over the streams or over the paths. However, the overall number of calls was much lower, so it was much harder to see a preference. I found the bat activity along the woodland streams was more variable. There were activity peaks in May, again in June, and then in late August. However, when I looked at the precipitation, which we know can affect the activity of bats, it did indeed rain on days 156 to 158. And I think this is what could have caused the suppression in activity here. So in fact, this could be a huge peak all through the summer for our bats flying. And again, some of these peaks, they could be linked to insects emerging, especially here in May, which is the time of a lot of insect emergence along water bodies. But to prove this, I do need to carry on and do a bit more work. Cool. So overall, the activity was higher along the woodland streams than the woodland paths. There we go. And overall, I saw an increase in bat activity with temperature. Although the data was highly variable, 53% of bat activity along woodland paths could be explained by temperature. It's pretty huge. Over half of their activity can be explained just by temperature alone. So the temperature had a greater effect along the woodland streams. Although it was more variable, the actual increase in temperature on these warmer days meant there was a lot more activity. And this again could be because an increased temperature is meaning more insects are around, there's more insects to feed on, and the bats have more reasons to visit the streams. The activity of barbastelle, common, and soprano pipistrelle all increased with mean night temperature along the streams, but nocturnal didn't. I tested these relationships with simple linear regression, and I won't bore you with the details today, but I found all three of those relationships to be significant and quite strongly significant. I then tested again, and I saw that the activity of barbastelle and soprano pipistrelle increased with the mean night temperature along paths, but nocturnal and common pipistrelle didn't. Again, the relationships that were found were tested and were significant. And I think this is quite important, and it does show that each of these species are reacting differently to temperature, and they react slightly differently along the woodland paths and along the woodland stream. And this should be borne in mind for any sort of climate change mitigation that is being undertaken. Cool. So looking a little bit closer at the woodlands that we've got, I want to talk a little bit about habitat quality. Some features of a high quality habitat are continuous vegetation along the stream. This gives cover and protections to the bats flying along the stream. Vegetation of multiple species and heights provides protection at different levels and increases biodiversity and feeding opportunities. Suitable surrounding habitat, such as broadleaf mixed woodland, shrubs, and unimproved grassland, all provide feeding opportunities and roosting opportunities for bats and help draw them into areas. And when they're in the area, they allow them to stay. So with this in mind, I wanted to compare the activity at my different sites. To stop seasonal variation, hiding everything else that was going on, I grouped the recordings by site and into peak and non-peak periods. The peak period was defined as May to August inclusive, following the Bat Survey's Good Practice Guide. And as we can see here, the activity did vary between sites and to a large extent. The greatest activity was recorded at Wood and Water Common and Danbury Country Park. Both are examples of good habitat quality and meet the criteria just mentioned. They've got complex vegetation along the stream that was surveyed, and the surrounding broadleaf habitat is very suitable for bats. When compared with the activity at Blake's, you can see it was much lower. Blake's only had an index there of 32.5. The stream at Blake's is slightly smaller, with a less well-defined void under the canopy for bats to fly in. When I took a walk along the stream, I also found that it had a few more gaps in the tree line and less coverage further upstream. It was similar where the recordings were taken, but this change in the quality of the habitat further upstream may have deterred bats from using this stream and getting to the area that I recorded in. In contrast, we actually found that the activity along the path was highest at Blakeswood. The path that we randomly selected to survey is actually a lovely covered ride with established vegetation on either side, which could provide that protection to commuting bats. So these results suggest that improvements to stream habitat, such as planting and maintenance of the flight corridor, would be very beneficial to bats. During the non-peak season, the highest bat activity was recorded along the woodland path at Paws Peace. The next highest activity was at Wood and Water Common, where the activity levels along the woodland stream and the woodland path were quite similar. Again, in the non-peak period, the number of recordings that I made was substantially lower, so some of those variations need more data to be looked into a little bit deeper. But it does show that along the woodland path at Paws Peace, that woodland path there is, again, I would suggest, quite an important commuting route for bats. Cool. So what about roosts? Where are bats going to sleep? So 18 bat roosts have been found in the woodland surrounding Danbury as part of the Danbury Barbastell project. 3 of those roosts that have been identified are practically on top of the streams, and there are another 2 within 10 metres of a stream. I wanted to compare how far these roosts were from the stream, so I went out and measured the distance from the streams and just plotted them on a simple histogram. And this graph here just shows that there is a bit of a non-random distribution to where these roosts are. We really do have a cluster of roosts quite close to the woodland stream. Even the roosts that could be sort of 20 metres away could well be one of the closest available features for a bat along that stream. So it does suggest a preference for streams, but it certainly says that streams are not the only thing going on when bats are looking for roosts. We've got some roosts here that are over half a kilometre away from the stream. So it's a factor, but it's certainly not the only factor. So again, I had a look at these roosts and I wanted to see spatially how they compared to the land and the streams within our woodland. You can see that there are multiple roosts right next to the streams and a few further away at almost all the sites. So there's not one area where they're all clustered, they are really spread out between the sites, and there are little areas here where they are lining up along the streams, both in Wood and Water Common and this little group in Danbury Country Park. So I tried a very coarse method of comparing the location of these roosts with some randomly generated points. The idea being that the completely randomly generated points would show absolutely no preference for being near a stream. So if the bats were choosing to be near the stream, the two results would differ. The average distance between a roost and a stream was 141 metres. The average distance between the random point and the stream was 247 metres, considerably higher. You would think this would be enough, but statistically, the difference was not significant. It was only just not significant, which suggests that more data is required. It's most likely due to the small number of roosts we have analysed and the high variability in data. I believe that stream presence is just one factor bats are using to choose between roosts in these woodlands. So, as we all need a little break from the graphs, here's one of our great roosts that we found. It's located almost on top of a stream, and it was found by our very own Lyndon Reed. And we've got a beautiful picture here of a brown long-eared bat at the top and a Dubuenton's bat at the bottom here, and they were both found within this roost. You can see here that this is the roost tree, and it is practically on top of that stream there. It'll be very easy for the bat to fly out of the roost and straight over that stream and feed or commute or whatever it needs to do. It's right there. And this is another one of our roosts. It's located 41 metres away from the stream, so quite a bit further, but it's been occupied on a number of occasions by nocturnal. So there was no way I could do a talk without including this nocturnal bat. And it's just interesting to see that this is actually our roost that's been used on the most occasions while surveyed. And it really isn't very far away from the stream. In the winter, when I went to look at it, you can see the stream just about when you stand underneath the roost that's in the distance down there. It's hidden a bit by the trees in this picture. This is another one of our roost trees. You can see the stream in the foreground here. This is quite a common occurrence for our streams. They go through patches of being really quite small. And at the back here, you can see the roost tree. It's the tree where you can see the bright heartwood against the darker bark and this black sort of marking here. And here are lovely pipistrelles that have been found roosting in this tree. Again, from this open area here, you could see how easy it could be for a bat to use this stream and use the roost and then get back to the stream again. Okay, so another graph, bear with me. Overall, I found an increase in activity through the spring. There was a peak in late summer and a decrease going into winter. This won't surprise many of you at all. But I didn't find this in all locations or all species. When I looked at the activity in winter and at low temperatures, I was quite surprised with what I found. Not through a lack of trying, we didn't manage to record a single barbastelle call in Blake's Wood at this site in November, December or January, but we got huge numbers in July, suggesting that their summer roost may be close by. Whereas at a different site just down the road, we found a peak in activity in December at Wood and Water Common. We had more bats flying along the stream in December than we did in June, July or August. And although there was a couple unseasonably warm days in December, it certainly wasn't warmer than it was in June, July or August. And these just results highlight to me the importance of different woodland areas and different woodlands throughout the year and how the bats' use of these woodlands may be changing. So it may not surprise some of you that we targeted the barbastelle for this because barbastelle are said to be a cold tolerant species. They hibernate in caves, often in the more exposed positions than other bats towards the cave entrance or even on the outside of the cave. They roost in trees under lifting bark, which can offer less protection than other features and will fly in milder spells in the winter, particularly in woodlands. We've not been alone in this discovery. all across the country, people are finding that barbers are flying around in the milder days in the winter in woodlands. So temperature was expected to have a slightly smaller effect on barbastel. We found along the woodland paths that 17% of barbastel activity could be explained by temperature. This is much lower than 43% for common pipistrelles. However, along the streams, we actually found that 34% of activity could be explained by temperature. It was higher than the other species recorded, but still pretty low, and low when it was compared against other comparable research that's going on. So we recorded barbastel flying throughout the winter and in very cold conditions, as low as 2 degrees. So that's not just on your warmer nights, that is pretty cold. And we didn't record a couple calls, but we've actually recorded over 157 barbastel calls on nights that are lower than 10 degrees. So the time they were flying, the moment that call was recorded, it was recorded to be 10 degrees. And there are still a couple more calls to look through in some of our other sites that aren't used in this presentation. So that got me thinking about what's going with the other bats. Cool. So again, nocturnal followed this general trend at both the two locations. The maximum activity was observed in the summer with a lovely peak in activity over July in both Blakeswood and Woodham Water Common. It's doing what the book says, which is nice. However, we did still record calls in both October and December, and we got nocturnal calls recorded as low as 7 degrees Celsius. Again, pretty chilly. Yeah. Similarly, soprano pipistrelle showed the greatest activity in the summer, but again, we found them echolocating in the winter and at relatively low temperatures. We found 59 calls on the 15th of October in 2019, and the temperature recorded was 12 degrees. We then found 9 calls on the 18th of December, when it was again 12 degrees, so a nice mild day. And we've got 2 calls at just 6 degrees in December a bit later on. Again, common pipistrelle showed the same sort of pattern. Most activity in the middle of summer, but some activity being recorded in both October and December, with 14 calls recorded on the 16th of December, when the temperature recorded was just 6 degrees. So these numbers demonstrate that although the activity is much higher in the summer, the bats are not simply just hibernating all winter in these woodlands. And to fully understand the use of the site, the survey should take place in more than one season. It's also very important to note when you're looking at tree works, such as coppicing through the winter, and the idea that bats aren't going to move between roosts, I don't think can always apply. It's very important to check a potential roost feature immediately prior to felling, regardless of the season, because bats could be flying around and they could commute, they could move between these roosts, especially on warm nights. So, if I've inspired you a little bit to go out looking for some bats in the winter, it's very important to focus your effort around the warmer nights. We found large numbers of recordings on the warm nights in winter. For example, on one night, we got 114 barbastel calls. That was on the 10th of December, so right in the middle of winter. The temperature recorded was 11 degrees, and we got no other recordings that whole week when the temperature fell. Also, don't expect the battery on your static detector to last very long at all in the cold temperatures. So I've just thrown quite a lot at you, but the headline points are: we found more activity along the woodland streams than woodland paths. We found woodland streams, however small, were useful for bats and should be protected from development, degradation and pollution. We find that increasing the quality and quantity of woodland streams would be beneficial to barbastel, common and soprano pipistrelle, and that each of these species reacted differently to temperature, and that winter surveys should be considered in surveys of areas and land management. Cool. Well, thank you very much for coming. And again, to everyone that helped in the data collection, it has been very much a approach of mine, and I've been helped greatly by a couple members of the back group, namely Graham and Alex Herr and Lyndon, in getting some of this data. To thank the landowners and managers that have continued to allow us to record the data, as I said, and to the Essex back group for letting me use their equipment. So, any questions?